with again bringing you another session covering data engineering question answers. And in today's session, we're going to talk about iterative functionalities of Python collection. Now, in the previous session, we were introduced with different types of Python collections, such as tuple, list, set, and dictionaries. And in this session, we're going to talk about how we can process the individual elements, each and every element of those collections in a simpler and faster way. So, as usual, before starting off, I'll just give my brief introduction. I have been working in data engineering domain for almost 9 years with various projects and involved in creating data pipelines for several clients. I also train candidates in this field to help them build an interview-ready profile with our comprehensive course covering all the necessary topics of data engineering. Now, so this session is mostly gonna be a practical one. I'm gonna be do some live coding, and you'll follow how these this iterative functionalities work. So if I talk about doing iterations on collections and process each and every individual element, in that case, the two main functionalities that comes into my mind in Python, that is the first one is comprehensions, and the second one is the lambda or the lambda expressions. So the comprehensions are nothing but keeping the task or the assignments or any sort of functions in just one line away instead of looping them using the conventional for or while loop, and then creating another set of collections using the previous set. So when I'll be showing you the live example, in that case you'll understand what I mean and how it works. But if I talk about lambda expression, this is something really different. And so there's a certain way of writing lambda expressions. And obviously, lambda expression doesn't work alone. It works with two different kind of methods. One is the map, the other one is the filter. Okay. So what is map, how it works, and how it is different from filter? I will also explain all these things when I'll be showing you the live demo. So just know one thing, to use the lambda expression, what we have to do is simply use the keyword lambda, then there are going to be the arguments followed by the arguments, which are the parameters of each and every individual element of the collection. Then there's the colon to separate the task or the assignment and the arguments. Okay, the assignment of the task is simply the function that I want to implement on each and every element of the collections. Okay, so and I have to wrap it up using a map method or a filter, and then they will work on the collections cumulatively. So let's just not waste too much of time and get into my Jupyter notebook. Okay, so I have this list ready. That is some simple integers 1, 2, 3, 4, 5, 6. And suppose I want to create another list out of it, which will be nothing but the double value of each and every element. That is 2, 4, 6, and so on. So the most basic or the simpler way of doing it is simply just call it in a for loop. So I'm gonna call the element as C for E in A. That is A the list. I will just do multiplication of each and every element, and then I will append it to a new list. So to append to a new list, obviously I have to create an empty new list. To create an empty list, I will simply put empty parenthesis over here, and then I'll be appending to this B list that I just created for each and every element. And as you know, if I want to add any element to a list, in that case I have to use the append keyword. So if I do this, and at the end, if I try to showcase the B list, if you can see all the values have been doubled up, right? But what if I tell you there is a better way of doing it, and it's much simpler and much more efficient? Then just take a look at my newer code. Okay. So A list is there, B is gonna be my resultant list, and watch what I'm writing. Is it giving me the same result? Yes, obviously. And the task that I'm doing is almost the same. Not almost the same. It's actually the same task, just the different way of writing it. Okay. If you can see this part for E in A, so that's something that I also declared when I was looping through each and every element. So this is like each and every element indicated as E from the A list, and then for each and every element, I have to return E into 2 in this new list, that is B. So that is why I'm wrapping up with this new list B. So E into 2 is meaning that I want to simply double up value. Okay. So this strategy is known as the list comprehension. So since I'm working with a list, it is known as list comprehension. had it been set or tuple or dictionary, in that case it would have been called set comprehension or dictionary comprehension for that matter. So suppose I want to modify it a more. I just want to double the values for only the even elements. Okay. So in order to do that, I have to present a if guard. If guard means I have to put some conditional statement over here. So how am I gonna do it? So this will return e into 2 if e is divisible by 2. So this is the statement, right? Just dividing by 2 and the remainder is 0. That means it is divisible by 2, which means it's an even. So if I try to print the list B now, you can see only 3 elements are contained. Why? Because there are only 3 values which are even, 2, 4 and 6. If I just simply double them up, then 2 becomes 4, 4 becomes 8 and 6 becomes 12. Okay. So if I want to edit this, if I want to say do some more processing, that the even one should be doubled up and the odd one should be tripled up. So how do I achieve that? In that case, there are some syntactical changes that would come in. One is, first of all, I'm removing this if part from here. Okay, and I'm gonna put it before the for loop expression. And with that, I'm gonna also have to introduce else, because there is obviously the values which are not divisible by 2, which are odd. So in those cases, I want to return e into 3, that is tripling the amount. So now if I run this one, you can see the difference, right? The 1 has become 3, 2 is now 4, because 2 is an even number, so it is doubled up. 1 was an odd number, so it was tripled. And similarly, 3 is odd, so it is tripled. 9, 4, again 8, doubled, even once doubled. 5, 15, 6, 12. Okay, so on. So this is another. So this is just in one line, I'm kind of processing all the elements in the collection or the list, and accordingly I am creating the new list. Had it been using a for loop, in that case I have to put some if statement, then else statement, then the return function, right? That would have been a little tedious, even though it's just a one line of thing. But you can understand that how smoothly it works. So this is how the list comprehension works. And similarly, we have dictionary comprehension as well. I'm showing the dictionary because each and every element is represented by key value, right? So it's a bit different than the list set and tuples, the key value ones. Okay. So suppose I have a dictionary over here that is, say, name is the key, first element, and then it is Edward, and then there's he has an age, obviously. So just let me give 35. Okay. So now I have a dictionary of 2 key value pairs, name and inward, and I want to only the dictionary. I want to keep the key value pair only for the name and only for the name value. Okay. I mean whatever the key that name has. So I can simply just do d of name. In that case, what it would return? It would return the value of that key. But what if I want to return the whole key value set, right? In that case, I can use a dictionary comprehension. So watch what I'm writing. Okay, so let me just run this and explain the code. Now it is giving me the key value pair for the name and Edward, right? That's what I wanted. So basically, d dot items will show you all the key value pairs that is inside the dictionary, right? That's what I showed in the previous example, or sorry, in the previous session. So if I iterate over the each and every key value pair, so I have 2 elements. One is the key, the other one is the value. Now I will return a dictionary using those key value if the key name has the name. Okay, so that's what I'm trying to do. Similarly, over here I was putting that if the element is divisible by 2. So similarly, over here now the key will always be unique. There's only going to be one name. There's only going to be one each. If I try to put another name and then say something else, in that case it would take the later one. Okay, so if I put something like name and then say this one John, so let's see what happens. So it will take the John one, because ultimately the D will consist of name John and age 35. The key will be updated. Okay, so this doesn't make any sense, because I mean it's of our prior knowledge that the dictionaries will hold only the unique set of keys. Right? So I will just put the name and Edward. So this is how the dictionary comprehension works. So I can iterate over each and every key value pair, just like I was iterating over each and every element in the list. Okay. Now let's come into the lambda expression. Now, when I did cover the lambda expression, I did mention that it works with two different set of methods. One is the map, the other one is the filter. So what is map and filter? So let me talk about map. Map is a method that will simply process or iterate over the elements in your collection, that is list or set, tuple, whatever you want to use, and then it will simply do the processing the way you define it. It's much like list computation, but there is a basic difference. Okay, so let me just achieve the same thing using a lambda expression. So how would it look like? I have to use the map method, and inside I have to introduce the lambda expression. Now, as I said, there would be a keyword lambda followed by the arguments, and this is e, the nothing but the element or the parameter that will be passing through. And I want e into 2. Mind that I'm going to be using the this original a list. Okay, so I'm trying to double up each and every value of the list, and so this is it. Okay, this is all I have to create. Simply, I'm just using the a list, and for each and every element, I am using this lambda expression to double up the value. Okay, so whatever expression that I put over here, it will be worked upon each and every element. Now, if I run this, it won't show me any value because this only creates a map object. Okay, so if I want to convert this into a list, I will simply use the list wrapper function, and then it will give me the required result, that is the 2, 4, 6, 8, 10, 12. Okay, now suppose the thing is, from this original list A, I want to only pick the odd numbers. Okay, so in order to do that, there is a newer method called the filter. So what is the difference between the filter and the map? Map will take any function, but filter will only take lambda expressions. Okay, sorry, filter will only take boolean expressions. So, okay, so map will return something, but boolean will always return true or false. So it will simply check whether your condition that you're giving is met or not, it is satisfied or not. So over here, let me use the lambda expression over here as usual. So instead of e into 2, I will check if e is divisible by 2. That means if the element is even or not. And as usual, I'm going to be using the same list. So this will again, it will just return, okay, something wrong. The expression cannot contain assignment. Okay, yeah, there is this typo. Sorry. So this will again return a filter object. It is not kind of like returning anything. So if I want to see the list how it looks after excluding all the odd numbers, in that case, yeah, just convert it to list and only the 2, 4, 6, the 3 even elements. So this is the basically difference between the map and filter. Now you might be wondering that how map with the lambda expression is different from the list comprehension. Is that lambda expression it's not like it can only take one line of function, but you can have a customized function and then you can use it. Okay, I accidentally deleted the last cell. Is there any way I can undo this? Okay, no. But let me just figure out what to do. Yeah. So where was I? Okay. So suppose I have a customized function that I want to only process the even numbers of the list. So I can do like multiply or double even. Double even, it will simply take an argument e and it will just check if e is greater than 0, sorry, divisible by 2, then it will return, the function will return e into 2. Right? So I'm going to run this function, but I haven't called it, I just declared the function. Now I'm going to call it using the map lambda. Okay, so for each and every element, instead of calling in any expression anonymous function, so I will call this function double even, and now I will use it on the original list, that is 8. So what I'm doing is that I'm calling this function for each and every element of 8. Okay. So obviously I have to wrap it up with the list method, or otherwise simply doesn't make any sense. Okay, so now the difference over here. So using the for comprehension, sorry, using the list comprehension, I was able to pull off only the even numbers and double them up. But now, even though I'm doubling the even numbers, but still I'm getting this none, right? So basically, how do I get rid of this none? So I have to do a chain processing where I have to use a filter again, using this expression that it shouldn't contain the none. Okay, let me try that. So I'm gonna call this even list, and now what I'm writing, I'm gonna use the filter function, read the lambda expression. Just let me use I instead of e. I have been using e for quite often. Okay, so now I should not be equals to, or I can put something like this, not none. So if I put that, and then okay, now here's the question. So which list should I put? Okay, should I be putting the original list or the newer list? Obviously, the none is in the newer list, right? The even list. So I'm gonna putting the even list to take the elements from, and at the end, last but not least, convert it into a list wrapper. So this will now return only the required ones for 812. It simply excludes the none values. So this is using the chain of events. We can use the map and filter. So you must be wondering that there are two lines of code that I'm writing and a lot of things. Why cannot I just use this one, right? This with the for comprehension, I can simply using an if guard, I can achieve the C. So what is the use of this map lambda expression? Why would I even need to use? The reason is being, see over here, the lambda expression is being called upon uh, for each and every element with a different function, different user customized function. I mean, this function is I have written. Logic could be anything that I write. Okay, but whereas when it comes to list comprehension, that is not possible. You cannot simply ingest any customized function that you have written and try to do the processing. So that's the main difference. That map with lambda can handle any function, whatever I define, but the list comprehension or any comprehension for that matter doesn't support that. So that is the basic difference between the comprehensions and the lambda expressions, and in which cases we should use the two. And that's all about this from this session. So if you need more clarity on this, just reach out to TextBox, reach out to us. You might be wondering that you are someone who's not good in Python. Probably you don't know the how to write definitions or functions at all, or you still need some clarity on how the list set they all look different. How can I use all loop, while loop in Python? Someone who is absolutely zero in Python. So we also covered the Python basic courses as well. We covered Python pandas as well, and then obviously PySpark, Hive, AWS, Hadoop, all will be there with coding as well as project implementation. So do reach out to us in case of any assistance you require. So I'll be signing off from this session. See you on the next session. Bye.
Contact us for the free job assistance. We will help you to get the IT job. Please like, subscribe, and share the channel for more regular updates from TechSpoke.